Hello everyone and welcome back to another VASAviation video. Today we're going to be talking about the fuel in aviation, fuel systems, refueling processes, and also fuel contamination and how dangerous it can be. We're going to be reviewing the video that I posted yesterday about Air India Boeing 787 fuel contamination or having some kind of fuel filter issues on board shortly after takeoff in Hong Kong, and the pilots requested to turn around back and land in Hong Kong. And maybe if this incident and this problem is related to the Air India crash in Ahmedabad only 1 week ago.
Technical reasons, sir, would like to stay closer to Hong Kong. Maybe we will come back and land back into Hong Kong once we sort out the problem. We don't want to continue further.
If I am able to advise the problem of the aircraft.
We have engine fuel filter right engine, and it says contamination can occur. We have done the checklist. We sorted out the problem.
And the AI315, so we say again the problem.
Engine fuel filter problem. Engine fuel filter problem.
So here's a diagram of the Boeing 787 fuel tanks. We have a left fuel tank, we have a right fuel tank, and also we have a center fuel tank. Unlike the aircraft that I fly, and I will talk about it just now because I will use some checklists and some diagrams so you can understand the importance of fuel filters. We only have in my aircraft, we only have two fuel tanks. We have one tank in the left wing and we have another tank in the right wing. The only purpose of the filter is just to block the contaminants, the particles that can be in the liquid, so that liquid can reach the final destination and for its purpose as clean as possible. So this checklist is from my aircraft. I fly a Cessna Citation XLS Plus right now, but it's pretty similar in all the family of the Citations. We have a message in the cockpit that we can show it's fuel filter bypass left and or right. As you can see, the checklist itself doesn't give you much information, or actually doesn't give you instructions to do anything about it. Indicates impending bypass or bypass of the fuel filter. It is possible that contaminated fuel has been introduced into both fuel tanks. Do not transfer fuel unless absolutely required. Monitor engine indications and consider possibility of partial or total loss of thrust from both engines. So basically, this message just indicates a potential fuel contamination inside of the aircraft and eventually get into the engines. So we have two dots underneath the message there, and it says if both sides land as soon as possible. So if we receive the message for both sides, fuel filter bypass left and fuel filter bypass right, we have a real problem, and that is a real indication that the fuel is contaminated, and at some point eventually that fuel will get to the engines and the engines will shut down. Possible, when it says possible, that means right now. Find a good place to land anywhere. It can be even a field or a short runway, but go there and put it down safely anywhere you can. If only the message is on one side, it says land as soon as practical. So it can be a fuel contamination as well. It can be another thing. It could be just a sensor problem or a filter issue there, but really not a problem with the fuel. So it says land as soon as practical. Now it's not land as soon as possible. It's land as soon as practical. That means, hey, you have a problem, not that bad. You can still find a good place to land where you have good emergency services or handling for your passengers. You still have time and you still can fly. When it's possible, when it says possible, it's like, hey, right away, go down, put it down safely anywhere you can.
So this is our bowl and filter.
So we need, of course, inspect the filter if there are no particles or some metallic debris.
Correct. So this video is courtesy of Zito on YouTube. The link is in the description. It's very cool how he removes the filter and he explains everything about it. It's a very good video and very related to what we're talking about. So like he said, he will check the filter for any particles or metallic debris or any kind of fog that can be in the fuel, and with the time, over time, it will stay in the filter. That's the final purpose of the filter, to just block all those particles there so the fuel can go through the filter as clean as possible. If this filter here gets blocked, because of some contaminants, and it can be, again, it can be just particles, it can be dust, it can be metallic parts, the degradation of the wing, of the fuel tank and the metallic parts there, or it can be water as well. It can be any contaminant there. If the filter over time gets blocked, then it's better to have a fuel, contaminated fuel get into the engine than just having no fuel at all. At the time I have no fuel at all, the engine will shut down. If I continue feeding the engine with contaminated fuel, at least I will have some time of the engine running until at some point the engine will shut down. So that's why the system has a bypass. So at the moment the filter gets blocked, the fuel will bypass the filter, will not be filtered anymore. So it will bypass the filter and get to the engine. At some point, the engine will be damaged because of that contamination, and it will shut down or even die finally. Back to the checklist of the fuel filter bypass message here. It says at one point in the warning note there, it says, do not transfer fuel unless absolutely required. This means, even though the fuel is the same in both wings, this means that maybe the fuel only in one wing is contaminated because of maybe a damage inside of that tank, particles there. So what you don't want is to transfer that contaminated fuel into the rest of the tanks and finally and eventually get into both engines. So let me explain how we transfer fuel in the airplanes, and if we don't, because my aircraft doesn't have the ability to transfer fuel, but we have another way of kind of doing it. So first of all, in my aircraft, we don't have the real ability to transfer fuel from one tank to another, at least when we are in flight. When we're on the ground, it's a different story. But when we're in flight, we are not able to directly move fuel from one tank to another. So what we have is the crossfeed, and this is what it means when we have the don't transfer fuel. It means, hey, just use the fuel in one tank to that engine, and separate the operation of the fuel tanks. So in the case of crossfeed that we have in the Cessna Citation, we can select, for example, left tank with that control there. It's in front of the captain side. We can control the left tank to the right engine. That means that the left tank will still continue to operate to the left engine, but also the left tank will now go to the right engine as well. So we'll be burning more left than right, and the right tank at that point will not be burning anything. This is something that we use very much in a real basis because, and this is very interesting in the Cessna Citation, and it's that we have an APU. So the APU is the auxiliary power unit that we have in the back, in the tail of the aircraft, and we use it on the ground for electrical supply. So when we're waiting for passengers and we need electricity in the aircraft to start powering up the aircraft and start setting up the FMC for the flight and everything, and also for the air conditioning, we use the APU, and that APU in the Cessna Citation, we only burn fuel from the right tank. So now imagine we have some delay on the flight, the passengers are not coming, or we have some other regulation delay, and we still have the APU running and the engines are still shut down, but we have the APU running and running and running for minutes and minutes. So we're only burning fuel from the right side. So at the point we get to taxi or when we are airborne, we have an imbalance from the right tank is way lower than the left tank. So we usually do the left tank to the right engine crossfeed position there. So we burn from the left tank to feed both the left and the right engine. So finally we get that balance, and at that point we can go back to crossfeed off. It's different in the Boeing 787 and bigger planes because they actually have the ability to directly transfer and move fuel from one tank to another. And that is through these fuel system controls in the Boeing 787. And again, I am not very familiar with this aircraft, so if you are a Boeing 787 pilot or you are familiar with it, I really appreciate your feedback and your comments here. So basically, we have 2 fuel pumps per fuel tank. We have 2 fuel pumps on the left side, 2 on the right side, and 2 for the center tank. We also have a crossfeed valve, as we do in the Cessna Citation, and then we have a balance button there at the bottom, and I guess that balance control there is just to control balance, to balance the fuel automatically so it can move fuel from one side to another, just to have both wings as balanced as possible. So as we saw with Zito, that was explaining that he was looking for particles or other kind of contaminants, metallic parts or anything inside of the filter, we have some contaminants that of course can be very, they can damage the engine and all the systems inside of the engine and the fuel tanks. But there's one contaminant that we maybe don't consider as contaminant, and it's water. And it's really important, and that's something that we have into consideration very much when we are learning as a student pilot, and also that we do much emphasis when we're teaching as well as flight instructors to our student pilots. And again, that's water in the fuel tanks. So this video is from Sporty's Pilot Shop showing their fuel drainers or fuel testers. We go underneath the wing with this instrument here so we can drain the fuel out of the tanks and test and check that the fuel is clean. It's very usual, especially in winter, overnight the air inside of the tanks condenses and converts into water. The water is denser than the fuel, so when you get in the morning, the next morning, the first flight of the day, and you drain the fuel tank, you will find some water in the fuel, and that's what you have to drain before going out and fly, because that water eventually can get into the engine, and the engine doesn't like water and it will shut down at some point. So it's really important that we drain the fuel tanks before every flight, or at least before the first flight of the day. I have some real photographs here from my flight academy. I think a couple of those photos are taken by myself. This is the difference, and you can see the contaminants there at the bottom of the drainer. We don't know if it was water, I don't remember, but you see there's a difference in color there. It can be anything, it could be dirty water, something, but you see the difference there. Sometimes you even drain a full drainer volume and you smell it, and it doesn't smell like fuel, and you actually touch it and it doesn't feel like fuel. So you drain a whole volume of the fuel tester and it was all water. So you have to continue draining and draining until you get rid of the water and it's all fuel inside of the tank. It's very, very important. Here's another picture. Now the difference is evident. You can see the difference between the fuel, the clear fuel on top, and some kind of contaminant drained out of the fuel tank. That's impressive, and that's a really cool photograph to show students how important it is to drain your fuel tanks before your flight. you don't know what's inside the fuel tank. There's no way we can go inside of the fuel tank. Maybe you can go inside of the fuel tank on a Boeing 787. Even with that, you don't know if there are particles there. You don't know if the metal is degrading, and at some point it will be particles as well, and that will get to the fuel filter. If the fuel filter fails, those particles will bypass the filter and go to the engine. So as we said, anything in the fuel that is not fuel can be considered as a contaminant. It can be water, it can be particles, metallic parts, microbial or microorganisms, anything is a contaminant. But we have some controls in the refueling process and all the processes that the fuel goes through from the very first point, all the fuel tracks and ships, and all the processes from the point to the aircraft. There are many processes, and the fuel needs to have the best quality as possible. Every time we refuel the aircraft, we receive this paper document from the fuel operator directly extracted from the fuel track, and it contains really good information about the fuel. First of all, at the top of the document, we can see the provider information of the fuel, the supplier again for the fuel with all the information. We have this number here so we can see all the process that this exact fuel has gone through from the very beginning to this point. We have the client information, that's my company, the product. We can see 1,585 liters. That's the amount of fuel that we have loaded up into the aircraft. The product, jet A1, that's the usual normal fuel used for jet airplanes. The aircraft information with the tail number, our type of aircraft, even the parking spot we were on at the time of the refueling, the flight information, origin airport and destination airport, refueler information and numbers, so we know the information about the fuel track, about the fuel operator. We can have all the information from the very beginning for that fuel up to this point. The temperature of the fuel at the time of the refueling, and then here we have the water detector test, and of course it has to be negative. They have some kind of processes and tests and sensors to detect all kind of contaminants in the fuel. The final purpose is to get the fuel to the aircraft as clean as possible with the best quality as possible. Now that we know about fuel contamination and the importance of the fuel filters, let's talk about two incidents. One of them is actually an accident related to fuel contamination. One of them is Cathay Pacific Flight 780. Without getting into much detail about this incident, you have to read the documentation about it. Basically, due to fuel contamination, the engines were being damaged because of this contamination, and the engines were not responding to pilot inputs on the throttle controls. First, it was only one engine, but when they were getting to the destination, it was two. Both engines were kind of failing and giving some problems and issues. So the pilots declared an emergency and mayday, and they landed safely. And finally, it was discovered that it was due to fuel contamination. And then probably the most famous accident in Heathrow and in London, and because of fuel contamination as well, is this British Airways Flight 38 into London Heathrow. Again, without getting into much detail, you need to read the documentation and the reports on this accident. It was due to fuel contamination as well. Some water ice crystals in the fuel kind of blocked the normal flow of fuel into the engines. So when they were approaching the runway on short final approach, about 3 or 4 miles away from the runway, both engines at the same time lost thrust. So now the question is, after this incident involving Air India with a fuel filter issue or some kind of warning message in the cockpit, can this be related to the Air India crash in Ahmedabad a week ago? Something that we know is that shortly after they rotated off the ground, a few seconds after, the aircraft started falling, probably because of total loss of thrust, and finally crashed. Can this be related? I hope we can find out very soon. Waiting for that report from the authorities. If you have any more information, please let me know in the comments. Also, if you know more about the fuel system of the Boeing 787 as well, let me know in the comments, please. And thank you very much for watching. See you in the next one.